Oof. Hello, test, 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 test. Audio check. Somebody give me an audio check. It works. It's 1300 on the East Coast, 1800 if you're in Greenwich, England. If you're in California, it's 10 o'clock in the morning and you're contemplating a bagel and lox. Thank you, Ugly Skull. Yes, Mr. Blodgett. This is in honor of our friend Tom Lipton, who is doing the big move and doing well. Warren says, are you done making noise now so I can enjoy my lunch? Yes, I am. For the moment. So, I'll tell you one thing. If you grind cast iron, it makes a mess. A black, yucky mess. However, the results are excellent. So, spending a little time cleaning up is not a bad idea. Hey, John. Welcome aboard, sir. So we had one question pop in already. Oh, we'll get to your question later, buddy. Don't let me forget. In fact, I got to put it on my list so we don't forget. Those questions come later. In Boston. I saw your picture from this morning, John, and it looked, well, all your pictures of Boston in the wee hours is beautiful. So, double time in Boston on a Sunday. Ooh, baby. Why did you mix cast iron dust with your hone stone dust? Because I had to. You do what you got to do. So I switched wheels. I switched processes. I came, I saw, I ground. And now we're cleaning up. We'll go back to stones. I got to make some minis next. And that's what you do. The machine works for you. You don't work for the machine. Let me grab. I gotta grab my my newly ground Windy Hill Foundry squares, and so I can show them to you. In fact, let me put this little protector down here. Okay. They came out fantastically well. I was very pleased with it. And we learned a lot of things. And we're going to talk about that today. Many things were learned. So we'll go over some of that stuff. So you know what? I'm going to answer a question earlier than usual, because I think I'll get it out of the way, and then we'll stay on topic here. So we have an antenna question, which I'm going to answer first, and then we'll get back to grinding. Chris, the pragmatic machinist, asks, why is a Yagi antennae called a Yagi? Well, thank you for asking, sir, and I will answer your question. I don't have one that I don't have to climb a ladder for, so I think you're just going to have to imagine a Yagi from last week. A Yagi antenna is a multi-element antenna where only one of the elements typically is driven, and the rest of the elements are parasitic. It means they're just sitting there. And first of all, the plural of the word antenna in the for somebody who designs and works with radio frequency antennas is antennas. Antennae is plural for insect antenna. So we don't say antennae. Just saying, it bugs me. It bugs me. All right, so Yagi is a name, and it was Professor Yagi. And if you look up the history, you'll find out that Professor Yagi had a assistant researcher. Today we would call that a graduate student working for him, and his name was Uda, U-D-A. So the proper name for the antenna is a Yagi-Uda array. And Yagi was the professor, and guess who did all the work? That's correct. Chris is blaming Siri for using the word antennae. Yeah, blame Siri. I get it. But anyway, so researcher, graduate student Uda probably got his doctorate. I don't know. Maybe he's Dr. Uda now. I should probably go look at the history a little more carefully. Worked for Professor Yagi. And I try to call it a Yagi-Uda array as much as possible. But it was the first antenna that demonstrated the practical use of a whole bunch of parasitic elements. So it's kind of like having a bell and a bunch of bells next to it, and if you strike one bell, the other bells could start ringing because they're at the resonant frequency or near the resonant frequency of the first bell. That's what a Yagi does. The driven element is like a bell, and all the other ones are like wine glasses. So that's the story of a Yagi-Uda array. And of course, because we're humans, we like to shorten things. We call it a Yagi, and then we forget that it's a name, so we go from an uppercase Y to a lowercase y, and we forget the history. But there's somebody behind that antenna, and that's who. It came from Japan, University of Tokyo, but probably I'm getting the name wrong. And there's a famous picture, which I should dig up, of the first Yagi antenna, or the first Yagi-Uda array on top of the roof of one of their buildings. And if you look at the design, it was stupid primitive, but it worked. So they're pretty cool. They're hard to design without a computer, I'll tell you that. But we have computers, and I've designed some glorious Yagi antennas, and they work great. I believe I have answered your question, Mr. Pragmatic Machinist. And if you disagree, you could let me know in the comments. So, if you're just tuning in, you're more to be pitied than envied. If you tuned in about 45 minutes ago when I started cleaning the machine, I'm sorry, but the machine needed cleaning. So, what's been going on? I took on a project starting the day before yesterday. I think I started it, but then yesterday I finished it. And that was these two beautiful Windy Hill Foundry squares, which I took from a raw casting, a beautiful casting, from Clark Easterling. And Clark owns Windy Hill Foundry and does a magnificent job. And I ground it in. Now, this is not super new. There's a video online and on Keith Rucker's channel, vintagemachinery.org, where he does exactly this. But I wanted to take a different angle on it. A different angle. At least I'm right. Oh, okay, so I wanted to... They're not squares, they're triangles. But I made two of them. So I would argue, Your Honor, that calling them a square is appropriate. Moving on. I wanted to do the whole project with the grinder and not start on the mill. That was just sort of my angle on it. For a lot of reasons. One of which is it was going to end up on the grinder. So if it could start on the grinder and stay on the grinder, it would be a little more efficient from a me point of view, not from a machine point of view. So I figured we'll give it a shot. So one of the things we learned from Keith Rucker's video is that he used a tooling square from solid rock machining. And this thing is just a piece of art. This belongs in the Modern Museum of Art. So Steve Barton over at Solid Rock Machining makes some really pretty projects, and Steve is one hell of a grinder hand. In fact, he's a master of the grinder. So this is full of ¼ holes. This is ground all over, and it's within 50 microns, or I shouldn't say that, 50 millionths square on all angles. It's really a beautiful square. So I chose to do what Keith Rucker did and use that as my reference and my clamping mechanism for the square. So if you go back to my posts, you'll see that I had the raw casting clamped up to this square. Now I had to use another couple of magnetic, there's a name for it, I'm forgetting the name, magnetically conductive blocks, to raise it up a little bit so that the ends of the Windy Hill squares can poke down lower than the tooling block, because this is only 5 inches and we needed more than 6 inches. So between the square poking out the top of the block and the 1 inch magnetic transfer blocks, that's it, and the 1 inch magnetic transfer blocks, it all seemed to work out. So I would grind one side, and then I would take the whole thing and just rotate it 90 degrees and put it back down. There was some cleaning involved, and hit the button and go do the other side. So that's what I did. And square number 1 came out. It was done, and while I had square number 2 started, I started measuring it. And what I found was I was out. This was leaning that way, 2.5 thousandths of an inch, a little more than that, closer to 3 thousandths of an inch of lean at the top. Totally unacceptable. So I reasoned. Actually, I didn't start number 2 until I measured that. So I reasoned that it moved in the roughing. So the roughing was, I was taking 0.75 thou, 3/4 of a thou per pass. I think I had it turned down from 1 thou per pass, and it was stepping over 1/10. And I was using the Norton 5 SG wheel, which we're going to talk about in a minute, which, by the way, is a big win. So there wasn't a ton of force, but I was able to see my load meter at least twitching when it was doing this grind. And I think between that and the vibration aspect of it, I think that the triangle or the square shifted, and that's where I got my error. So on the second one, I wonked it down much tighter. Now, Steve Barton pointed out in one of his posts, incorrectly, that my two outer clamps, which were touching here and here, were fine, but I had 2 clamps here, and there was no support underneath. And he said that's going to cause you some distortion. And in a post replying to Steve, I said, yeah, it's a trade-off. I need more pressure, but I don't want the distortion, but I need more pressure. So I did have them in there, and I figured, let's see what happens. Well, actually, it was insufficient. So on the second one, I wonked them down on the corners, and I still put as much pressure as I thought I'd dare on the center ones. That came out better, but not perfect and not acceptable. So that one came out tilted this way, and it was 5/10 out. No good. So when I was all done, I cleaned off the chuck and I reset up again. Same setup, except I used my cylinder square to tap it in perfectly. It was set up like this. So I had my cylinder square here. I had a square reference, and I tapped this in until it was perfect with the reference sitting on the chuck, a clean stoned chuck, okay? And then I tightened down my clamps, and I went and I did a fine pass. The first one was 0.04 of an inch, no greater cut than a 1/10. And the second one was I think it was 1/1000 of an inch, no greater cut than a 1/10. Otherwise, same recipe, and it came in perfect. So I believe what happened was that my hypothesis was correct, that the roughing shifted the work, and it wasn't able to survive going from roughing into the finishing and get the result I wanted. So that was a really good lesson. I think that if I had broken out roughing and finishing, which I had to do in the end, it would have worked better. Is it possible to have one setup and go right through to a finished surface? Yes, but it would have required much stronger clamping. And if I had to do it all over again, I think I know, well, I could design a better system, but it wasn't going to be easy. So going back and kissing it and finishing that, getting that angle exactly right was totally worth it. So I'm going to go grab my cylinder square because I want to talk about it. And yeah, no, so Almost Machining says it could have moved due to internal relief. I don't believe so. I don't think anything I observed would support that. And they were stress relieved. So can I prove what I just said? No. But by observation, that's what I think happened. I'm going to go grab my cylinder square. And I want you guys to put in the comments, are you familiar with a cylinder square, or are you not familiar with a cylinder square? And let me go grab it. Okay, I'm back. So Warren says yes, he is familiar with the cylinder square. Somebody had a question. Okay, let's address the question, and then we'll get into cylinder squares in some depth. And KR Blodgett says that he's seen the Suburban Tool grinding clips on cylinder squares. Good. Excellent. Okay. So we have in the shop here, one's on loan. We got two others, so that's 3. And one's a magnetic one, which technically is still a cylinder square, so there's 4. We have 4 different cylinder squares. Really, only 3 of them would I consider a true cylinder square. True. There's a joke. Okay. So nobody's jumping up and saying anything about cylinder squares, but I had all sorts of questions about them. So this is a Brown & Sharp model 558 cylinder square. It's hardened, it's ground all over, it's got well thought through bases with little grooves so that if you slide it around on a surface plate, the schmutz has a place to escape. And we're gonna. This is what I used, and we'll talk about this in a second. First, let me answer Indiana John's question. He says, "What is a good number for a step over when surface grinding heat-treated high carbon at say 1/2 thou depth of cut?" So let's answer that question. There's a million ways to do this, and you know what? There's no wrong answers. This is where you realize that grinding has so many variables that you get to choose. For example, I'm using a 1/2-inch wheel on this project, and on roughing, I was stepping over 100 thousandths. Because on roughing, you want to get across the work and just get the job done. And I was stepping down as much as I could stand for the power I had available and the setup I had available. And after considering that and watching the sparks, I settled on, let's just say 1/1000th of an inch. Because this is a machine that doesn't have a ton of power, so you're going to go fast. You know, it's the same as high-speed machining. And then for finishing, you divide that by 3. So I was stepping over at 35 thousandths when I did my finishing pass. And for me, that gave me an awesome result. It gave me an RA6 or better. It was quite nice. There's a whole deep topic about that I want to talk about one day. It's not going to be today, about step over and dressing and wheel wear. So that's going to be another day and this is stuff I'm learning. I don't want to sound like an expert. I'm just further down the road than some people and not as far down the road as others. So that was kind of interesting. So it depends what you need in the end. So that's a pretty wimpy answer to your question. But if you're roughing, take a big step over and use your wheel. And if you're finishing, take as small a step over as you need to achieve the results. I'm sorry. I gave you my numbers, so start there. Okay, let's talk about this magic tool called a cylinder square. So a cylinder square sits on a granite or whatever, and the side of it forms a right angle. And the reason a cylinder square, oh, you're welcome, Indiana John. We can talk about it more as you know we go on here. The reason a cylinder square is cool is because of the geometry. The cylinder makes it. There's a whole bunch of things that happens. So we'll do a little thought experiment here and talk about how the cylinder square gets developed and why it's a very good fundamental reference. So if you go back and read Foundations of Mechanical Accuracy, you learn that the first step is admitting you have a tool problem. No, the first step is having a flat surface. So, you know, Moore Special Tool went through great pains to auto-generate flat surfaces. And once they had a flat surface, they can go on to the next thing, which is perpendicularity. So how do you get perpendicularity? So one way you can get perpendicularity is you can make an angle, like one of these, except you make 3 of them, and you go again through the same process of putting them down on the surface plate, and then marking one against the other, and then scraping them in from A to B and B to C and C to A and A to B and B to, and go around that circle until all 3 of your right angles are marking up perfectly, and now you've just auto-generated a right angle. That's one way to do it. But now, what about let's go over to the lathe. So everybody either has a lathe or has a friend with a lathe, right? So go over to the lathe, chuck up a cylinder, okay, and cut yourself a cylinder on the lathe. Easy peasy lemon squeezy, right? Yeah, just like the surface plates. Exactly right, Indiana John. Auto generation. Yes. Okay. And then you have 3 of them when you're all done, which is cool. So let's go back to the lathe. We've just turned a cylinder. In fact, my stand for the iPhone here, I'll show you. It's kind of funny. All right, you just turned that cylinder. That's my phone stand. So you take that. Put you back here. Okay, you take that and let's face the end. Let's cut it off, flip it around, and face the end. So we just made something that looks a lot like this. So the first thing you're going to do is you're going to get out your micrometer and you're going to measure the OD at the top, in the middle, on the bottom, a couple other spots, and confirm that it is of uniform diameter. Okay? If it's not of uniform diameter, you got to fix that. Fine. That's all conventional machining so far. Or if you're grinding, maybe you have a cylindrical grinder, you know what to do. So you end up with this thing that has uniform diameter. Then you check for roundness, or maybe you did that in the first place, and you check the diameter as you rotate the cylinder. Check, 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 check. Check, 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 check. So you've done 2 checks on this thing to see if it is a cylinder. That's all you care about right now. Is it a cylinder? So the next thing we're going to do is we're going to take that cylinder that you just took off the lathe, and we're going to go over to the grinder, and we're going to make a flat surface on one end, and we're going to flip it over and make a flat surface on the other end. Now generally that means that our 2 ends are going to be parallel, but really that's all we know right now. We don't know anything else. We have 2 surfaces which are flat, we could measure that, and are parallel, we could measure that. Okay? So now, how do you know if it's square? So if I put it on my surface plate, and I look at, if I put it on my surface plate, and I look at my angle here, and I rotate it around, and look at my angle here, and I rotate it around, and look at my angle here, how do I know that those are going to be square? You don't. You have no idea if they're square. And here's the beauty part. It doesn't matter. Okay? What we do know is that there's going to be one side that's going to tip over the most that way, and then there's the other side that's going to tip over the least that way. Okay? You know what I mean. And we can identify that maximum. So if this thing is tipped over, we could rotate it around, and with some simple tools, we could find where it's tipping. And then we just mark that. Now, if you go 90 degrees away from that, you've got a right angle. And if you go 90 degrees the other way, you've got a right angle. And you can now take that, that cylinder and correct that lean. Common methods on the grinder. I'm not going to bore you with it. You could measure it, shim it, grind it, flip it, grind it, measure it again, and go around that loop a few times until the lean is gone. Once the lean is gone, you have a reference. What have we used? We used some pretty basic tools. We used very basic metrology, and all of the metrology we just used is used in a differential mode. I just care about the difference between this side and this side, the difference between this side and this side. I'm looking for a maximum. Notice there's no decimal point with a billion zeros after it. So you can generate with basic shop tools, and I'm including a surface grinder and a surface plate, but you can generate with basic shop tools this perfect cylinder. And now when you sit this perfect cylinder on your surface plate and you bring up a piece of work that you're measuring, and you come up to it and you touch it, and then you take a flashlight and you go behind it and you look at the flashlight coming through the crack, you now can evaluate your degree of squareness within microns. It's amazing. And what if the 17 guys that came before you in the shop wore out the base of your cylinder square from rubbing it or doing something stupid? If you take measurements around the circle, same thing. You'll know the answer. You'll know if it's out of square, and you can find the maximum tilt and the minimum tilt, split the difference, and you still have a square. So that geometry is magnificent, and that's why the cylinder square is the reference standard. And I have a little surprise coming for you in a second. But this cylinder square is very handy. It's still heavy, solid. Plus, my shop standard, my heat just came on. My shop standard is a 12-inch tall, I think it's 7-inch diameter Taft Pierce cylinder square that weighs 70 pounds, and that's the shop standard. So if I ever have to go back to my primary tools, that's the primary tool. Okay. Now I want to show you something on this Brown & Sharp model 558 that's super cool. Okay? There's a message on one end that says, this end up for true square. So when you set this on the table with this end up, it is a true square. But if you turn it over, there's another message that says maximum tilt. Okay? They have intentionally ground one of the faces so the cylinder is tilting. Why would you do that? Well, remember how we said before that it doesn't matter that it's tilted, it's still useful. They took it a step further and they calibrate. See those curves? And you see those numbers? They calibrate. It's a 558. Did I say something wrong? Yeah. They calibrate it. So now when you put this on the bench and you touch it to your work and you see some tilt, you start rotating the cylinder until you get a blackout. So what the cylinder is going to do is it's going to do this. As you're rotating, you're rotating, you're rotating, you're rotating. So at some point, it's going to black out. You stop, and now you read the number on the top, okay, where the top of your work crosses that curve, and that's the number of tenths of tilt you have in 6 inches. Is that not the coolest thing ever? So this is not only a cylinder square, it's a measurement tool, and it's handy. So that's why I like it. And they're all, you can find them, they're all over the place. You may choke on the price, but it's worth it, okay? I won't tell you how much I bought this one for, because you'll hate me, and I don't want you to hate me. So I think I want to stop there. There's other ways to measure perpendicularity. What do we call that? A squareness comparator. I have a very nice squareness comparator made by Taft Pierce, and you've seen. I'm sure you guys have seen it, where it slides around on a. It looks like an indicator stand, but it's a very good indicator stand. And you bump the bottom of it, and you have an indicator at the top. And of course, if you have a cylinder square, you could calibrate it so that your indicator on top reads 0, and then you have a tool you can run around and measure. Okay, Almost Machining is having an epiphany. Okay, I don't want to go off into the weeds on this too much because we've already. Hey, did Clark Easterling? Are you here? I don't know if you're here. So if you're here, drop me a comment. Clark threatened to show up, and somebody else who I messaged, I don't know if he took me seriously, but we'll see if he showed up. If either of you two guys know, and you know who you are here, please comment. But that's a cylinder square. I was a little surprised. Well, I wasn't so surprised, but there were a lot of guys that never used one, and it's a magnificent tool. And if you want to make one, make it. Don't worry about it being hard. Just go make it. Yes, Tom Lipton addressed cylinder squares. He made one. So Tom made a cylinder square from a piece of shafting material, 1045 chrome-plated shafting material. And he specifically did it to show how to make one on the cheap. So go look up Tom's video. And that's actually, I guess I'm advocating for that. If you're really curious, go make one. They're fantastic. And the nice thing about hydraulic cylinder rod drops is that their outer surface is this nice chrome-plated material, and it's very good material. So it's excellent material. Yeah. And also, if you buy a cheap import, cylinder square, it might be okay. And if it's not okay, you know how to. I just taught you how to evaluate it. So there you go, cylinder square. So do I get a check mark for cylinder squares? I think I do. We talked about that. Talked about that. Okay. So I want to talk about almost machining. I think you arrived at your epiphany. So when I started this project on the Windy Hill Foundry squares, castings, a gold star for cylinder squares. Excellent. Thank you, Warren. That's what I needed. So I bought these two castings from Clark Easterling, I think 2 years ago. It might have been more. And they sat on my bench. And I guess I could say I was aging them so that they were fully relaxed from the casting condition. But I just never got around to it. If you go to Windy Hill Foundry, I got 4 stars from the Pragmatic Machinist. If you go Google Windy Hill Foundry, you can buy these from Clark. So let me tell you about Clark. His material comes from disc brakes. He goes around and he buys disc brakes at scrap prices or a little above scrap prices. And that's his raw material that he melts down at his foundry and makes stuff with. And these castings are from that material. And I have to say, they're absolutely beautiful. So the material's good, his technique is good, and he does a stress relief step, and they're beautiful castings. And then you get a chance to machine or grind the way you want it. So when I started this process, I said, what wheel am I going to use? So shout out to Robin Renzetti. When I was working on the Brown and Sharp grinder that I had before this grinder, when I'd first gotten it, I had to grind in the table, which is a common process for grinders. And I started with the wrong wheel because I didn't know. And it was the result was terrible. I was getting a lot of burning. I think it was a white wheel, which is to say a simple aluminum oxide wheel. And it was not coming out well. So from posting to Instagram, Robin says, you're using the wrong wheel. You should be using a silicon carbide wheel on cast. So I got myself a, we commonly call these green wheels, mostly because they're green, but I'm going to have to take your word for it. So I got a green wheel. Actually, that's not true. I had this green wheel, and the reason I say I had it is because this was 100 grit. 100 grit is pretty fine, but it's what I had. So I asked Robin, my master, I said, this is what I have, can I use it? He says, yeah, just take it slow. So I did, and it worked stunningly well. And that was my lesson in grinding cast. So when it came along to this Hill Foundry project, my first thought was a green wheel. But I had this other wheel, which is a Norton 5SG. I see your question that came in. So there's a Norton 5SG. Okay, you can't tell much from the picture, although I am doing clever product placement. You keep seeing my balancing rings, which I sell over at my website at kineticprecision.com. You too can buy these balancing rings. That's a commercial. So anyway, I had this 5SG wheel. And the funny thing is, the reason I had the 5SG wheel is I had done some research for John Grimsmo of Grimsmo Knives, who makes magnificent knives, by the way, and great pens. And John Grimsmo was about to buy an Okamoto at the time that I was about to buy an Okamoto. So we were kind of talking about Okamotos, and he said what he was going to do, and he says, can you do some tests and tell me what might be a good wheel for the knife steel? So he sent me some knife blade blanks, and I did some experiments. Well, in my research, this 5SG wheel looked like it was going to be super skookum for stainless steels. And it was sort of their high-tech, one of their high-tech wheels. And I said, well, let me get one. So I bought one. And oh, by the way, it's at least double the price of normal, so-called normal wheels. Well, it turned out that it did a fantastic job on the stainless, and when I went back to John, that was my recommendation. So I had it, and it's a 46 grit grade I wheel in the Norton 5SG family. So I went back to the Norton datasheets, and the Norton datasheets say, this wheel is very good for everything. Basically said everything. Cast iron, stainless steel, tool steel, all on the list as being excellent for all of them. And I found this very hard to believe. So that's when I put the post up earlier this week, and I said, has anybody used this on cast? I'm going to do cast iron, and I'm going to try this wheel. Has anybody done that? So even Robin said, use silicon carbide. You're doing cast, use silicon carbide. But then interestingly, a couple of guys said, I've used this wheel on cast, and it works great. So I said, what the hell? It's an experiment. That's how we learn. And I went ahead and tried it. I really like it. So it did a great job on cast. It did, that's personal experience. It did a great job on stainless steel, a knife steel. That's personal experience. Haven't tried it on, tool steels, and I haven't tried it on soft steels, but this Norton 5SG. And then I found other guys. I found a post to Practical Machinists where Cash Masters, who has a huge, to me, huge grinding business up, I forget what state he's in, but if you watch the usual suspects on YouTube, he's done a lot of grinding for them. And he swears by that material. So I tried it, and it was awesome. So, yeah, the material's more expensive, but honestly, if you had to, if I had to have one wheel now in the shop, just one for metals, that's it. I'd be done. That's my very inexperienced, easily swayed opinion, and I'm sticking to it. 5SG from Norton. Hashtag not sponsored. I mean, actually, Norton has a lot of my money. All of the raw materials for PFG stones start life as a Norton stone, and I grind that material. So when you buy a PFG stone, you're buying a Norton base material with my magnificent grinding applied to it. PFG stones are available at pfg.gg. Check it out. That too is a commercial. Okay, I got a check mark for 5SG wheel. I might be buying a couple this week and just putting it in stock because I'm really digging it. And so that I have a 46 grit. I might get a 60 grit. My friend Walla Tool, who's on Instagram, he said that he's been doing a lot of 60i wheel. So I might get another 5SG in 46, and I also might get a 5SG in 60. We'll see what happens. Hey, Deer Valley Machine Works, welcome aboard. Okay, let's take the question. Are there any alternatives for tramming rings? Or would it be something I could make? Hey, Lanier Knives, welcome. Okay, so you got to help me out here. I don't know what a tramming ring is. I can make stuff up in my head, but I don't know what a tramming ring is. So give me an idea what a tramming ring is, and maybe we can sort this out. We learn best through ignorance. I just made that up. Write that down. We learn best through ignorance. And when you come to this channel, we have a lot of ignorance. So we're going to learn what tramming rings are. Anybody? Anybody? Okay, well, until we get some information on oh, here it is. Interesting that SG works for so many things. I'm grinding some titanium and 904 stainless at work. I might try one of those wheels. Thanks for the tip. You're welcome for the tip. Check the data sheet first. No idea about titanium, but the stainless, probably it'll work. It's like a washer looking cylinder square for getting a mill in trim. I think you mean tram. I have no idea. I have no idea. We could noodle that out some more if you want to. Maybe for next week, we could take that as homework. Send me some pictures, sketches, something sketchy. Okay, we'll have something for next week. Tramming the Bridgeport. Okay, I'm getting it. So you're tramming your Bridgeport. Can the cylinder square help you? Is that what you're saying? I think that's what you're saying. Spencer Tool and Grind says, waste of time, tram off the bed. Yeah, but hang on. I know what you're saying. Okay. So, if I was going to tram a Bridgeport, I would use an extension rod and an indicator touching on the bed, and I would spin it around in a circle, and by measuring at 12 o'clock, 6 o'clock, 3 o'clock, 9 o'clock, or northeast, southwest, I would have all the information I need to get the tilt, the head tilt, and the head nod and the head rotation measured and sorted out. So I guess there's some rings that people put down on the table and then sweep on the ring. There's a bunch of ways you could do it. I don't think a cylinder square is super useful. Now, I have a friend of mine So ONL10 says the data sheet for 5SG mentioned titanium as well. Thanks again. You're welcome again, and thank you for telling me about titanium. Yeah, I think maybe tramming is another day's topic. I have opinions about tramming. Sometimes we make it way more complicated than we need to make it. And the bed's in pretty rough shape. Yeah, so my recommendation there is I don't know what my recommendation is yet. Send your bed to Cash Masters to have it ground. That's my recommendation. See how I tied that back? Okay. Sorry. Any other questions? Ask them in the comments or put them in the thingy with the button. We did the Yagi. I got that on my list. Let me mention something I was thinking about, and tell me if I'm crazy. I was originally going to take the two angles here, and after I had done the sides, the beautiful, beautiful sides, I was going to put them together, okay? And then I was going to mount them up together and then do both sides together. And what I was going to do was I was going to super glue them together. What do you think of that idea? Because super glue, you know, a little acetone and a little patience, and you could break that bond. I've done this before for fixturing, but why not fixturing on the grinder? Furthermore, Your Honor, I would offer that gluing after clamping and indicating and getting everything tightened up, using super glue between the tooling block and the work might have also been interesting. I don't know. Let me know what you think about using super glue for fixturing. I've used it quite a bit, and I've done some thin, very thin plate work where I literally super glue the plate to a sacrificial aluminum plate, did my machining, and then popped it off using a little heat applied to the back of the fixture plate, and that worked awesomely well. Yeah, KR Blodgett correctly states, surely the glue takes up some space. It does take up some space. And if that matters, yeah. It's a really fine, it's a good question. And stop calling me Shirley. All right. Any other questions for today? I'm all questioned out. I'm gonna have some tea while you put a question in the thing. Hot glue. So Thad Radcater says hot glue for lock? Question mark. Hot glue is interesting. I know John Saunders had a clever technique that I think he stole from someone else, who probably stole it from someone else, which is do window machining. He was doing this on the 5-axis. Do window machining, and then hot glue it, and then do your final tab cuts. I thought that was pretty brilliant. Local hobby store sells different viscosities of super glue. They have a very thin one, and you use it frequently. Yeah, that's what I'm talking about. I have, not Hobby Lobby, thank you. I have the thin one also. Oh, I have a tip about that. If you buy the thin, the primordial cyanoacrylate glue, and you buy it in the little teensy-weensy containers, you know, those little tiny like foil containers, and you buy a box of them with, you know, 25 of those, I find that to be a really good way to buy them, because you start a project, you need a few drops of super glue. You're only opening up a tiny little thing, and then inevitably when you forget it and it kicks on you and you throw it out, you're not wasting a whole bunch of super glue. So that's what I did. I bought actually 3 boxes of like 25 of those little tiny things, and very happy about that. Fad Radcater says, I have some rust on the spindle pulley. Worry? I think you'll be forgiven. It depends how long you've been married. Okay, sorry. Spindle pulley. No, it's going to wear your belt out, and it may throw off some balance. But get some of the WD-40 rust remover. It's a direct competitor to Evapor-Rust. You can get some Evapor-Rust too. Soak a paper towel. Put the paper towel where the rust is. Keep it wet and ignore it for a couple hours. Fad Radcater says, very impressed with JB Weld instant glue. Honestly, once you're down to the thin stuff, you're down to a cyanoacrylate glue, they're all going to be the same. Okay. I hope I answered your question, sir. It's 1:56. We got 4 minutes before the top of the hour. We like to end before the top of the hour, so you guys can get on to your other Sunday requirements. Thank you for being here. Appreciate it. We had a good crew today. Yeah. Well, so the only reason I like the WD-40 rust remover over the Evapor-Rust, and I've used both, is that I can go down the street to my hardware store and they have the WD-40. That's the only reason. So I don't have to stock a ton of it. I know that I'm 15 minutes away from WD-40 rust remover. Thank you, Spencer Tool and Grind. You have the best name ever. Hey, that's the nicest thing ever. Don't do me a favor, if you want them soon, don't order the minis, because that's my next thing. But everything else I think I have in stock. ONL10 says, I appreciate all your free tips and info. By the way, they're worth every penny. You have converted me to a customer. I will finally order some of your stones tomorrow. Thank you, sir. You're very kind. Yeah. Okay, so I'll close with a commercial. If you guys are interested in PFG stones, and if maybe you don't even know what I'm talking about, go over to PFG.GG. That stands for Precision Flat Ground. Precision Flat Ground.GG. It doesn't mean anything else. PFG.GG, and check it out. Once you get there, you could also find your way to the page on balancing rings for the Sopco 200 hub, which is and close allies, which is the most popular hub for small grinders. And one day, not today, you'll find a link to the balancing stand, which I have to get to. No, it's not muriatic acid. No. Evapor-Rust and WD-40 rust remover are very closely the same thing, and neither one of them are muriatic acid, period. Wrong. It is a very cool chemical technology. Trust me, I did all the research. This is not just muriatic acid, okay? And yes, you can bathe in the stuff and it's not going to hurt you. It's very cool. It's closer to and I'm going to sound like I know what I'm talking about, but I don't. It's very close to a chelation process if you're a chemistry person. Yeah, so if you bought used auction sign plates and such, do the rust soak first, and then after it's all nice and dry and clean, then apply the stones, and you're on your way to a working tool. Miguel Rodriguez 7474, bienvenido, and you're just in time for us to say goodbye. So watch for the video; it'll be up soon. I have to apologize for the video, by the way. It's going to have 45 minutes of me standing around. I might edit that out. Indiana John says muriatic acid is perfect for the exact opposite of removing rust. That is true. Okay, 2 o'clock. You guys are awesome. Thanks for being there. We'll see you on the all the usual channels. Be safe. Go make some fun stuff in the shop.